Welcome, everyone. Today, we are zipping into the electrifying universe of EV lithium battery. Just a minute, you'll get everything you need. This is Sylvia, by the way, who has conducted research on EV battery and AI modeling over past a few years. In the upcoming video series, I'll keep you posted on DIY your own AI models to check your battery's health conditions. So, if these topics really interest you, please don't forget to subscribe to the channel for more information. In this three-part video series, we'll cover topics including what's inside a lithium battery, why lithium battery dominates EV market, and I'll show you some ideas about lithium battery degradation, and you will know why do batteries fade even when they are just sitting there. Not only for the EV battery, but also think about batteries used in your daily life, from the phone to the laptops. Generally, they are all use lithium batteries. In the first part, let's have a quick look of what is inside a lithium battery. Think of a lithium battery as a supercharged energy box that powers up almost everything in your life. But have you ever wondered what's actually inside this magic box? Let's take a peek under the hood to see what makes it tick. The lithium battery can be described as an energy storage technology whose cathode materials include lithium and typically also contains other metal elements. It's the movement of lithium ions that makes the magic happen and leads to charging and discharging processes. An easy way to understand is consider that when using it to power your EV and any other devices, this is a process for the discharging. But energy stored in such a box is limited. So normally, before use it to power your devices, you may need to charge it, and this is charging. Therefore, the charging and discharging creates a continuous circle, where the elements can flow back and forth in reverse directions, as shown in these figures. However, there is a trick. These elements would move randomly if no one gave them a direction. But such magic requires a directed movement. So engineers' minds came up with a solution by applying a force to push the element along. This force is what we call a potential difference or voltage. It creates between the two ends of the battery, thereby giving metal elements, giving lithium ions to a clear direction to flow. The two ends are called cathode and anode electrodes. You can think about them. They act like serving as the starting and ending points for lithium ions transport. Additionally, there are electrolytes within the battery, who serves as a medium and allows the ions to move between the two electrodes. But there is another crucial challenge. These two electrodes must not touch, as doing so would eliminate the voltage, the potential difference. Without the potential difference, the force that drives the lithium ions would disappear. Therefore, you see what? Here is a separator. It is placed between the two electrons, acting as a protective gate. As for current collector, what is its function? You can see both sides have a current collector. You remember these figures? In addition to lithium-ion transport between two sides, there are electrons flowing through an external circuit. For example, in this discharging process, these electrons generate a flow to power your devices. So current collectors are positioned on both the cathode and anode sides, acting like a signal tower. They gather all the electrons produced and direct them into the external circuit. This can ensure the electricity reaches the devices where it is needed. Therefore, the current collector plays a very important role in efficiently channeling energy, making sure that no power is lost on the way. I hope you now have a clear picture of what's going on inside your battery. We have already talked about some topics about the inside elements and some processings in a very simple way. I hope so. And in the next chapter, we'll dive into why lithium batteries are the true champions of the EV market. So hope you can subscribe this channel and follow us. See ya in the next video.